Have you ever felt totally overwhelmed by a piece of technology that was actually supposed to make your life easier? Yeah, that feeling, that's right at the heart of what we're digging into today. We're talking about that critical, sometimes dangerous gap between how systems are designed and how we humans actually use them in the real world. It all boils down to one simple, undeniable fact. We are not machines. Our brains are incredible, for sure, but they have limits. And when we design these super complex systems, in hospitals, airplane cockpits, power plants, and we forget this basic truth, we're basically setting the stage for failure. Okay, picture this. You're an operator in a control room. All of a sudden, alarms just start cascading, red lights are flashing everywhere, sirens are blaring. And within seconds, you have dozens, then hundreds of alerts all screaming for your attention at the same time. This is what's known as the alarm flood. It is the perfect example of a system completely overwhelming its human user, making it totally impossible to tell what's a real crisis and what's just noise. Now, what's so fascinating here is the gap this whole situation reveals. See, on paper, in the manual, there's a neat little procedure for every single alarm. We call that work as imagined. But in reality, when those alarms are firing off faster than any human could possibly read them, people have to adapt. They have to improvise, they have to prioritize on the spot. And that's work is done. The space between those two, that's where all the unmanaged risk is hiding. And that leads to this absolutely crucial point. We can't just keep piling on more alerts, more procedures, more layers of complexity and hope for the best. These systems have to be designed with our human capabilities baked in from the very beginning. They have to be engineered with purpose, not just accumulated piece by piece over time. So this alarm flood idea, it's not just some abstract problem for a control room. It's a pattern, a type of system failure that has real and often tragic consequences across so many of our most critical industries. Back in 1999, this landmark report from the U.S. Institute of Medicine just sent shockwaves through the entire healthcare world. It revealed that a huge number of deaths were caused by medical errors. But here's the kicker. It wasn't because of bad doctors or incompetent nurses. It was because of poorly designed systems that made it easy to make a mistake. That was a game-changing moment that started to shift the focus from blaming people to fixing the system itself. And you see this pattern everywhere, right? It's not unique to any one field. In healthcare, a confusing interface on a machine or just a crushing workload can easily lead to medication errors. In aviation, pilots can get into what's called mode confusion, where they're not totally sure what the autopilot is doing. In the nuclear industry, as people have gone from manually turning dials to just supervising computers, it creates totally new challenges. See, these aren't just one-off human mistakes. They are predictable, system-induced errors. And the costs, they're just staggering. Beyond the heartbreaking accidents and disasters, these poorly designed systems lead to chronic stress, to massive employee burnout and high turnover. They also create this really toxic culture of fear and blame, where the person who makes the inevitable mistake gets punished, but the root cause in the system is never fixed, just sitting there, waiting for the next person to fall into the exact same trap. So, if blaming people doesn't work, and it doesn't, what's the alternative? Well, the answer lies in this really powerful scientific discipline that's designed specifically to tackle these kinds of problems. It's called Human Factors and Ergonomics, or HFE for short. And really, it's all about designing for the human. It's not about trying to change people to fit a rigid system. No, it flips that completely. It's about changing the system, the tools, the tasks, the whole environment, to fit the natural capabilities and limitations of people. It's a proactive, scientific way to make work safer and just plain better. This really gets at the core mindset shift. The old way of thinking is what we call the bad apple theory. Something goes wrong, you find the person who messed up, and you blame or retrain them. The HFE systems approach asks a much, much smarter question. Why was it even possible for this error to happen in the first place? It assumes that people are trying to do a good job and instead hunts for the flaws in the system that set them up to fail. And then it fixes those, which makes the system safer for everybody. Okay, so that's the theory. But what does this actually look like in practice? How do we go about designing for the messy reality of the world instead of some idealized fantasy of how work is supposed to get done? Well, it all comes back to closing that gap we talked about, the one between work as imagined and work as done. Human factors specialists, they don't just sit in an office reading the instruction manuals. They go out into the real world, the hospital ward, the factory floor, the cockpit, to understand that messy reality of work, with all its interruptions, its pressures, and its clever workarounds. The goal is to make the official way of working, the imagined way, actually support the real work that has to happen. And they do this through a really rigorous three-step process. First up is analysis. That's where experts literally observe and map out how work gets done to really understand the context. Then comes the design phase, where all that knowledge is used to build or redesign tools, software, and processes. And finally, and this part is absolutely crucial, is test and validation. They bring in real users to test the new designs in realistic simulations to make sure everything works the way it's supposed to before it gets rolled out into a high-stakes environment. The principles that guide all this work today are just fascinating. This isn't just about how comfy your office chair is anymore. It's about cognitive load. How much information can a person realistically handle at once? It's about understanding that with automation, our role has shifted from being the doer to being the supervisor. And as AI gets more and more common, HFE is becoming critical to make sure that AI is a true partner we can trust, not just another confusing black box. But here's the thing, you can have the best design technology in the world, but it's still not enough. To truly make our systems safe and resilient, you have to build a deep-seated culture of safety. A truly great safety culture doesn't just ask, are we following the rules? It's constantly asking, how can we get even better? It stops treating safety like a checkbox exercise and starts treating it like a core value. It's about moving beyond just reacting to failures and instead proactively hunting for weaknesses and anticipating risks before they turn into incidents. Now, the gold standard for this is what's called a generative safety culture. In these kinds of organizations, safety isn't just some department down the hall, it's just how everybody does their job. Leaders are actively looking for and rewarding people for being safe. When things do go wrong, the investigation is all about finding the system causes, not finding a scapegoat. And maybe most importantly, the organization is just relentlessly curious, always searching for that next hidden problem before it finds them. So, that brings us to the final thought I want to leave you with. This isn't just about nuclear power plants or operating rooms. I want you to look around your own world. Your job, the tools you use, even your own life. Where do you see that gap between the official procedure and the way things actually get done? Because recognizing that gap, that's the very first step toward building a safer, smarter, and much more human-centered world for all of us.